So let's have conversations. In 310, we did things at the end that says like the external force is trying to do what to our shoulders. We just kind of played fast and loose with it. But like the external forces are trying to horizontally abduct me, right? So my internal forces are trying to horizontally adduct me. So we muscles that pull that way, we just call them the horizontal adduction pullers, the horizontal adductors. And then eventually at the end of this class, we're going to give names to those muscles. Okay? In biomechanics, I want to break down the linear and the angular. Okay? So linear kinetics. What is the bar trying to do to our hands? Because think about it, the bar's not touching my muscles. The bar's touching my hands. That's all it is. The bar is trying to push my hands down. Make sense? That's linear kinetics. What do my hands feel? My hands feel the bar pushing it down. That doesn't mean it's going to go down, but it's pushing down. Okay? What does the bar feel? The bar feels my hands pushing up. Linear kinematics. Well, if I don't see any motion, that's kinematic. I'm not moving. No motion of the bar, no motion of my hands. Staying still. I'm at a constant velocity. A constant velocity can be a constant zero. If the bar starts to go down, let's talk linear kinetics. My hand is going to feel less push from the bar. Thus, the bar is going to feel less push from my hand. Thus, gravity is going to be allowed to speed the bar up, coming down. That's linear kinematic. The bar speeding up, coming down. The bar getting faster as it travels down is motion description. And because F is equal to ma, if something's changing its motion, it's got to be because of something else. So if the bar is speeding up, if the bar is changing its motion has to be because of something. In this case, it's gravity. We're letting gravity be greater. We're letting gravity. And the acceleration is negative because it's speeding up, going down. Negative force of gravity is speeding it up, going down. See how those things match? Negative for negative, positive for positive, zero for zero. A constant speed going down, though, it's not accelerating when it's going at the same speed. True? When you hit cruise control on your car, you don't keep pressing the gas pedal. So all I need you to see is that if it's at a constant speed, it's not speeding up, it's not slowing down, then there is no positive or negative unbalanced force that's causing it to speed up and slow down. The forces have to be balanced. My hands and the bar feel each other again for whatever that weight is. They're feeling each other. Slowing down, coming down, though, you know that you're going to have to start pushing more than that weight. You know, because remember, we don't chest balance in this class, right? You know when it starts to get down to the bottom, you're going to start pushing more than the weight. You're going to give that bar more linear push from your hands than planet Earth is pulling down on it. And that will positively accelerate the bar. It's going to slow the bar down while it's falling down. And the only thing that can do that is a positive unbalanced force. If I'm going to slow it down going down, then immediately speed it up going up, it's going to continue to positively accelerate. Because of my continuous push more than the weight. Slow and controlled, I don't need to keep pushing more than the weight to keep it going at the same speed. If I kept pushing more than the weight, I'd throw it out of my hands. Once you get the furniture moving, it's not as hard to keep it moving. True? Once you get it moving, you're like, okay, we got the hardest thing is to get the furniture moving, right? It's not as hard to keep it going. Because you don't have to keep the engraver. You just have to tie. So those are just examples of linear. The angular conversations is, we kind of did that at 310. The bar is trying to do what to my shoulders? I'm not trying to rotate the bar, but the bar is trying to horizontally abduct my shoulders. So that is a moment. Is the bar pushing down my hands a force? Yes. But because it has a moment arm, The bar is trying to create a horizontal abduction torque or moment at my shoulders. That's a angular kinetic concept. The bar is applying a moment or torque of, heck, in 310 we said, what's the external force trying to do? That is an angular kinetic question. It's creating a torque or a moment that is horizontal abduction. Now, we could get into real nerdy mechanical things and positive torques and negative torques. There's just no motion. I mean, we know motion. The angular kinematic conversation is, well, what am I observing? I'm not observing any motion. So that torque isn't trying to, or it's still trying to do something, but I'm not doing anything. So that means my internal torque must be equal to the external torque. The amount of force that's trying to rotate me this way is balanced or countered by the amount of force from my muscles trying to rotate me that way. And if I lower it down, external torque is still trying to rotate me this way, and my muscles are still trying to rotate me this way. It's just my muscles are going to let off. Because what do you think is going to ultimately, the hand is just representing what your muscles are pulling on the rope. So it's just going to let off. It's just going to pull a little less. It's not that it turns off. If it turns off, it'll do this. And the last thing, you want muscles that are going in the same direction. It's just going to not pull as much. And that's weird. That's a little weird. But like I always say, if you're playing tug of war with the person you babysitting, sometimes you got to let off to let them in and make them happy to get that fit. It's not that she's not pulling, it's just you're going to let off a little bit. Okay? Now, what I would like to do is rearrange the computer so that we can see the screen. Sorry about that, guys. I don't know what that was about. What I would like to do, oh, were you filming me?
Yeah.
Oh, bless your heart. Good job, Mary. Keep it up. I thought I always default to I did something that I don't remember.
No, you're so correct.
Okay, this segues to our lab, which will eventually segue to our feet. Sometimes when we do feet examples, we don't feel it because we got socks, we got shoes, and we don't have as many nerve sensors as we do with our hands, right? So the next step to feeling these concepts that I'm hoping we feel is the little lab that I posted, okay? So what I would like for us to do in small groups, or it could be the group like me with the different voices in your heads. But ideally, I want you to think about it. All you're doing is inverting the bench press. That's all you're doing. Instead of a fixed U with movable bar, you have a fixed bar and movable U. But what I'm hoping that we see or feel is that when I'm not moving, what the ground feels for me has to be the same as what I feel from the ground. And if I stay tied, I'm never going to go anywhere. I have to let off. Now, when I say let off, you don't do this, but you have to pull your hands away from the floor just a little bit to let planet Earth start speeding you up. And I'm hoping you feel that. And then what I also hope you feel, you got to do it slow and controlled. But once you let off a little bit, when you're going at the same speed down, you're doing your weight again. But to slow yourself down takes more push, and to speed yourself up coming up takes more push. Now, where does Campbell? Here I could hold this position all day. If I stopped halfway, I can't hold that. That's harder here. Yes, but not because of the linearity, because of the angularity, because of the angular kinetics. When I'm locked out, there's zero moment happening in my elbow. There's less of a moment happening in my shoulder. But if I stop halfway, the linear stuff's the same. But now all of a sudden, I have a heck of a lot more moment happening. Look how far away this push is from my shoulder, whereas here is a lot closer. So the angular kinetics change, which means my muscles have to work more, but that doesn't mean I'm linearly pushing any harder. It just means that my muscles are kind of at a disadvantage because the external force is at more of an advantage angle. So that's why sometimes in these middle ranges, it feels harder because angularly it is. But linearly, at the end of the day, it's still, am I pushing more than my weight or am I not pushing more than my weight? Does that make sense? Okay. So let's use this lab. Work your way down. There's a scale that's measuring how much force is pushing from his hands, holding the starting position of the push-up. This force is 150 pounds of total force from the ground to his hands. 110, right? 75, 75. So if his hands, Newton's third law, if his hands feel, guys, that's what a scale does. What a scale does, you step on it, you're pushing on the scale, and the scale pushes back on you. And as long as nothing is dynamic, nothing's accelerating, those things are going to be equal. Okay? So make this observation with the bench press. How does he come down? He's got to let off a little bit. He has to let off a little bit. He can't keep pushing at 150 pounds and nothing's ever going to happen. You have to let off. And then you got to be more. And then you got to let off. And think about it. The top of your push-up is like the easiest thing, the best part, right? Like you go down and like imagine like you're struggling. You're like, oh, Kelly Clarkson. The top part is where you gotta breathe. Because you know who slowed you down right at the top? Planet Earth. But you know who's not going to slow you down at the bottom? Planet Earth is going to slow you down at the bottom. Two things are either going to slow you down on the bottom. Your muscles working through your hands or the ground. Right? One of those two things. So that's what this lab is about. Hopefully you guys spread around and literally trying to feel what I'm showing you. How there's going to be fluctuations of pushing more and pushing less. And if you go slow and control, you're going to push with equal. We will eventually get to life isn't about slow and control, just like we did with 310. Right? Mosquito, I'm not going to do this. I'm going to go faster. There's going to be times where you don't want to go slow and control. We're going to let gravity speed me up, and then, man, I got to put on my muscles to change my direction. Okay, let's try that last. Move around the country. You can do modified push-ups. You can do wall push-ups. If, let's say you have a shoulder injury or something, you can do it. You can do it from the perspective of the wall. But you're still going to be pushing less and more to influence your motion. I'm sorry.
That's okay.
It was just.
No, I knew that you thought that you.
Oh yeah.
That you were like doing stuff, so I was like, I'm just
No,
trying
you
to
did great. You know what really caught me? We had that conversation at the end, and I thought for some reason,
like forget.
yeah. And then I started feeling like a weirdo.
No. Okay. But like I knew that you didn't like think that, so I was like, whatever. I'm gonna like I turned. No. I wasn't gonna like correct you. Whatever.
Well, I don't do this anymore.
No, yeah, I know. There's one person. I don't know if we can find out who it is.
Well, my mom. It might be me. I would think most people that watch it say I'll watch it later.
Yeah, it's true. Because I guess you can also be like commenting when you get things just so you know. Whenever I'm here, I like make sure there's no questions that you might forget to check.
This is so new.
All the technology stuff.
Like I had to just getting this thing set up was crazy.
I
had to.
The Ethernet.
The ether wouldn't go to the new computer, so I had
Get
to
an
get
adapter.
an adapter.
Oh.
Then I thought that was only one plug-in, and apparently there's this like hidden like lip
Yeah.
that I magically just discovered. Like I was like Columbus, like it's
Yeah.
like.
So funny.
Guys, it's important to know I am not going to ask you to graph on your test. The graphing could help us answer and understand. That's why I introduced this to you guys. It's just to show you why things are. But I'm not going to be like graph this exercise.
And then there's this last issue of negative. So it's into that the line is below it was so good. Like on that very bottom. Yes. So all of this would be negative velocity. But this is negative acceleration, this is positive. So anything below is negative velocity.
It's negative acceleration because it's going towards the
Yes.
acceleration
Coming up, but both of these are negative velocity.
The movement, yeah, you're going down. That would be like, that this is the push. But this would be like, speed up, this right here, this triangle would be like if you were doing as many push-ups as you can. Like free falling and coming, right? So like no constant. Where like you speed up going down and you slow down going down. So this would be slow down. Where you got to ground.
Okay.
So it's actually the ground pushing on you, that's slowing you down. And the ground pushing on you is up, right? That's what you want. Because it's not the ground that's accelerating. Here, it's gravity that's accelerating.
Okay.
So that the negative force is speed, but it's positive push. So you push that positive speed.
So that would be.
Going down. Slowly. Coming back up
But this is just like for a split moment. Like for a split second. Like this is the majority of your whereas this is just a little change.
Absolutely.
Yeah. I was like, what? Just see who
All of this in here. So versus, you don't do that. Some other guys. But if it's slowing down. So it's me trying to push the ground down because I don't even rely on all that. So it's specifically positive push from the ground. That's what's slowing down. That's what's
The slopes in this below here. Now I
Guys, if y'all are looking, some people are graph people and some people are not. I'm not gonna make you graph in the test. But if you like graphs to help see and feel, the push-up would be more like this. Speed up, like it'd be literally like a squat. It's just we don't feel our feet as much as we would do our hands. But it's the same trend. Speed up, going down, cruise control, slow down, going down, speed up, coming up, cruise control, slow down, going up. Speed up, going down, cruise control, going down, slow down, going down. Change my direction at the bottom, speed up, coming up, cruise control, coming up, slow down, coming up. That's because I let gravity do it. That's because I'm high gravity. That's because I'm greater than gravity. I'm going to continue with greater than gravity. I'm going to high gravity. I'm going to let gravity be greater. It's the same trend. It's just it's really hard to kind of feel letting off on the ground on the squat.
And the constant so that's also rather than the bar. So here's rather wants to ground, like give the person
So math is almost like I have to do it, but it's almost like you're not going to take So it is this this and this.
I see yeah, when you work more, I'm not going to do less than
Let's say planet Earth is pulling down with 150, and so ground is pushing back up. That's how the instruction. Whatever I'm pushing on the ground, the transactions happen in balance, but they don't have to. I can't make this great, and that's another great thing. Is that
just going down. Oh, no, this is all very.
All right, guys, let's go. I can figure this out. I'm going to go over this trend real quick, even though it's for the top graph. And again, if you're not a graph person, not a big deal. I'm never going to make a graph on the test. They had a tough time seeing it, so I want to make sure we really get the. Okay, so think of it like this. The air squat follows the same rules as the push-up. The ground's going to be pushing on me at the same amount of force planet Earth is pulling on me. Oh gosh, I thought it was like falling back. Miriam, you messed with my mind today. Guys, if they stay tied, I'm never going to move. I have to literally pull my feet away from the ground. Look what happens if I do it extremely. That's an extreme pull. So it's gradual. Even though you may not see it because your feet technically stay touching the ground, you're pulling your feet away a little bit. You are thus pushing less on the ground, so therefore the ground is pushing less on you, and therefore planet Earth can be greater. It's the same thing happening in the push-up. So we are going to speed up going down because we're letting planet Earth be greater. And planet Earth is pulling down, right? That's why this is a negative acceleration. We're letting planet Earth speed me up. Think of it like this. It is impossible to go down on a push-up faster than what planet Earth could do. You just let your hands go, boom, you can't go faster than that. Okay? But I can control if I want to go slower than that in terms of the speed. And that's what we want to do, control. Okay. You speed up going down. At B to C, that's a slow and controlled. Nice, constant, easy, consistent motion going down, right? Slow and controlled. So in other words, I'm not doing my push-ups like this. Like those dudes like do all that stuff. That's awesome. That ain't me, Jack. I'm doing it like this. And you can feel it at the bottom. You gotta give it more. You gotta push more to change your direction at the bottom. Because planet Earth ain't gonna do that for you. You have to do it. So slow and controlled, constant speed means, it doesn't mean you're not pushing, it's just that you don't have to keep pushing less or pushing more. You're just gonna push with what you need to keep it going at the same speed. Cruise control. Time. But then this is where your muscles got to step up, right? What speeds up must slow down. And remember, we're not banging our chest on the ground. Our muscles pulling on bones, bones pushing on things. We're going to start to push more onto the ground so that the positive acceleration, the positive push from the ground is what's going to slow us down as we go down. So this is where my graph people, this might look like the velocity is going up, but it's not. I'm still in negative land. I'm still going down. My speed is getting slower and slower and slower as I go down. Because think about it, this is 0. I was moving at a certain speed, certain velocity, so my velocity is just getting closer and closer to 0. I'm going 3 miles an hour, 2 miles an hour, 1 mile an hour. 0. The acceleration is positive because the force that's responsible for that change in velocity is positive. So think about it. I sped up going down. Who did it? Your instinct is, well, technically my muscles did it. But if I was in outer space, I could pull my hands up and not do anything. Do you see my point? Technically, it was planet Earth that sped you up. Your muscles allowed it to do it just a little bit. But it was planet Earth. It was the negative acceleration from Earth that lets you speed up going down. Then your muscles chose to tie. Then your muscle chose to be greater, slow you down going down. Your muscles continue to be greater coming back up, speed you up coming up. Tie is a constant speed, and then the best part, right at the end when you get to relax, you let off to let planet Earth slow you down. Planet Earth's going to slow you down one way or another. If you do it slow and controlled, it's going to be a nice, easy slow down. But planet Earth could also slow you down like this. I mean, like, it's going to slow you down. And in that case, it sped me up. The only reason I'm using the graph is to give a visual to what I'm trying to say, because sometimes it gets confusing matching up. This force is greater, thus this acceleration is positive or negative, thus you're speeding up or slowing down. Does that make sense? So what? What am I going to need for the test? That's a great question. All I'm asking us to be able to see on the test is something like, okay, guys, you're in a push-up. He's holding that position. He's holding that position, constant 0 velocity. What's his acceleration? It's not speeding up or slowing down. His acceleration 0. Okay? Which of the following would be a linear kinetic variable? He feels positive y, or I could say up or down. His hands feel upward push from the ground. That's a linear kinetic variable. I could say he speeds up coming down during the push-up. He lowers himself down. He speeds up. Now, guys, I think in our mind, we think of speeding up like in a car. Like we think of like punching it, but it doesn't have to be that way. The elevator speeds you up going down, but you don't want it to go fast. It's just a little bit. A little bit is still something. So speeding up on the way down is a kinematic. That's a motion variable, right? Speeding up must be accelerating. He's speeding up going down. That has to be negative acceleration. Remember on the board, I put positive acceleration is either speeding up in a positive or slowing down in the negative. Remember that? So I sped up in the negative. It has to be because of a negative force. You can't have a positive on the left side of the equation and a negative on the right side. You can't say $20 is equal to negative $20. So if the acceleration is negative, that meant whatever the object that did the force has to be negative. That's the only negative force in the system is planet Earth. Like I'm just showing you how you can kind of prove these things. On the test, I'm either, again, the push-up to me is a segue to the squat, but I love this one. Because we're limited to our body weight on a push-up. What if you stack plates up? We're not as limited to body weight on something like a bench press, right? So what if I specifically ask this question? During a repetition of a bench press, there is going to be a period of that movement description where he has to slow the bar down while it's traveling down. Now, if we were going to go angular, I'd say slowing down the horizontal abduction, right? But if we're talking linear, I'll just say slow the bar down while it's going down. Can gravity do that? No way. Well, what's influencing the bar besides gravity? Your hands. What direction are your hands influencing the bar? Up or positive? So if you're slowing down the bar as it falls down, that can only be done by the push from your hands being more than the weight. God, you're doing more than what you think you're doing. So what is the force that slowed the bar down while it was going down? Your hands, the push from your hands. What's the direction of that force? Up, positive Y. What is the acceleration? Well, if the force, the unbalanced force is positive, the acceleration has to be positive. Positive left side has to be positive right side. Speeding the bar up, going up. Still your hands, more than the weight. Positive acceleration. You know what the only thing that changes is the actual direction of the speed or the velocity. Meaning, when I'm slowing it down, going down, it's moving down. And when I'm speeding it up, going up, it's going up. But the acceleration is still positive. Because of my hands pushing more than the weight, still positive. Think of it like this. If I'm bouncing a basketball, the ground is going to have to slow the ball down as it falls down, change its direction, and speed the ball up coming up. True? So that ball is positively accelerating, even though it's going down and then coming up. Because that push from the ground was on it the whole time. Once it leaves the ground, planet Earth will slow it down. And planet Earth, if I miss my dribble, will speed it up. That's the kind of things I'm going to ask on the test. If it's angular, it's going to be about the joints. Flexions, extensions, abductions, and adductions. If it's angular, it's going to be about what rotation is that bar trying to do to me, and what rotation are my muscles trying to do to me. That's angular, kinetic, and kinematic conversations. The torques or the moments, internal and external, affect our joint motions. But linearly, it's all about the hands and the bar going up and down. To me, that's the most important part of the test. Do you know what linear, kinetic, and kinematic variables mean? And do you know what angular, kinetic, and kinematic variables mean? Angular is going to be torques and moments. I'm not asking you to solve for any of that stuff, but that bar is trying to horizontally abduct my shoulder. It's trying to create a torque in that direction. So my muscles are trying to horizontally abduct my shoulders. They're creating a torque in the other direction. We did this in 310. So what happens if you observe horizontal abduction? I'll give you a motion. Oh, well, these muscles responsible for that, want to remember that stuff? It's about linking forces and movement changes. That's all it is. So angular, moments, torques, joint motions. Linear, ups and downs. Bar going up, bar going down. And at the end of the day, and it's weird, but it's true, yes, muscles are pulling in directions of rotation, but at the end of the day, it's what that bar is feeling from those hands. Less, more, or the same. If the bar is feeling less push from the hands versus gravity, you're going to be speeding up and slowing down, you're going to be accelerating. And if the bar feels more push on it from the hands than planet Earth, you're going to be accelerating. Like that's what this class is really about. Why do so many therapists emphasize slow and controlled motion? It's not that that's always the best. It's just that for that entire range of motion that you're doing the same speed, you're actually doing the weight. Okay? What I put here is just to practice your definitions, but like Acceleration is change in velocity over time. A much easier way of saying that is how much time did it take you to change your speed? How much time did it take you to speed up? How much time did it take you to slow down? And that's why I didn't have time today, but like if we were doing like a vertical jump, I actually don't want to go slow and controlled. Like, I don't want to do a max vertical jump and be like, okay, I got this. I actually want to pull my feet off the ground more to let gravity speed me up more, to change my mass in motion, to change my momentum. Remember, guys, momentum and impulse are just rearranging F is equal to ma. Now, here's what's cool. Gravity is going to have more time to speed me up, meaning when it comes time to slow myself down, I'm moving at a much higher speed. So doesn't it make sense that it's going to take a lot more push from the ground? It's going to take a lot more force to change my direction down here. Yeah. As opposed to if I was barely moving, doesn't take as much to change my direction. Those are the kind of things I'm hoping that we can see and apply. And the reason I use graphs isn't because I want you to graph. It's to show you these trends. To show you why gravity is a negative accelerator. Why the push from the ground is a positive accelerator. That kind of stuff. Okay?
Do you ever the lab answers?
Oh, yeah, sure.
So that they like study it.
Yeah.
Probably just explain.
No, it's great. Describe the linear kinematics in the y direction, ups and downs. The person holds the position on the top. No acceleration. However, the velocity would be 0, not moving. We're going to see those two things don't always have to match up. Describe the linear kinematics in the y direction. The person starts to come down, speeding up, coming down. Okay? Speeding up, coming down. You're getting faster as you go down. You are negatively accelerating. You got faster going down. To me, seeing the kinematics, because that's what we do. We see motion. It's hard to see forces. Seeing the motion tells you the force. In other words, if I know I'm negatively accelerating, I got to look for a negative force responsible for it. The only negative force is planet Earth. So that shows you that I had to pull off a little bit to let planet Earth speed me up coming down. Okay? Oh gosh, sorry guys. Well, I guess now you have it. You can look on your own. I used to use a chalkboard and it was efficient. All right. Person starts to come down. Describe the linear kinematics if the person comes down at the same constant velocity. So here's the deal. The acceleration is 0, but you have negative velocity. You do that all the time in an elevator. You're coming down on an elevator, you have negative velocity, but I hope you're not accelerating. I hope you're not getting faster. The only time you hope to accelerate is when it comes time to stop at your floor, which will be a positive acceleration. Because the floor is going to push up on you more than planet Earth is. Make sense? So your velocity is negative, but you're not accelerating because you're no longer getting faster or slower. Okay? Linear kinematics, why a person slows down. Slowing down on the way down has to be a positive acceleration. Because gravity can't do that. Gravity can't speed you up and slow you down. That'd be some Dr. Strange wizardry stuff. So if you, and maybe it just helps you to memorize, positive acceleration is either speeding up, going up, or slowing down, going down. And so in this case, I tell you, hey, you slow down on the way down for a push-up, that's got to be a positive acceleration. What's the only positive force acting on me? The force from the ground in my hands. That has to be greater than my body weight or my weight. So it's kind of weird. We do F is equal to ma because it's cause and effect. Forces make changes in motion. But honestly, just like we did in 310, the clues are in motion. That's what we can see. We don't see these arrows. But we can observe, speed up, slow down, stay the same, and then reverse engineer it to say, well, if I'm staying the same, then I know these have to be equal. If I'm speeding up, how am I speeding up or down? Oh, I'm speeding up going down. I know whatever has to be negative. Remember, no graphing on the text. You could graph if that helps you, but it's all about seeing forces and motion relationships in the ups and the downs in terms of application questions. All right, guys, let's come back up. When you come back up, you got to speed up. Right? You got to speed up coming up. You got to speed up in the positive. Positive acceleration because of a positive unbalanced force, meaning that whatever is influencing you in the positive has to be greater than whatever is influencing you in the negative. What is that? Push on your hands from the ground. Has to be greater. Now again, this is where it gets a little confusing because you're like, well, wait, wouldn't I be pushing on the ground with more force? Absolutely. But unless you're Chuck Norris, you're not going to move the ground. Nobody said Chuck Norris does push-ups, pushes the earth down. So whatever I give the ground, it gives back to me. But if I don't have the ground there, I'm not going anywhere. So I am pushing on the ground, but I don't feel that. The ground feels that. I feel the ground pushing back on me in the positive. Make sense? So that messes with people because they're like, well, wait, aren't I pushing in the negative? Absolutely, you are. But the ground's not going anywhere. So you get back from the ground. No different than what stopped me and brought me back the other way, not me pushing this way. It's the wall pushing back that way. Because if the wall wasn't there, it's not about this. It's about what I get back. That's all I want y'all to be able to see. You guys were playing kickball while I was jogging around the track at 0.05 miles per hour. Put up there. But it's the same thing. The ball's coming at you in one speed, let's say that's negative. To change its velocity, you got to slow it down rolling to you so that you could speed it up the other way. So the ball has to experience acceleration in the same direction. That's going to slow it down, and the same acceleration is going to speed it up. What was that acceleration from? Your foot. And it's not even about like when we were in elementary school, this would happen all the time. Like you go to kick and you miss or something like that. It's not just about the motion. It's literally the collision. It's the contact. That's all I'm trying to get us to see. Forces change objects in motion. Linearly and angularly. Angular conversation is just going to be about joint motion. The linear, though, is literally going to be about gravity and what you're pushing on. Because remember, muscles pull on bones, but bones push on things. All right, was that helpful? We're going to have a review on Monday. Definitions, definitions, definitions. If we're going to do this project where we're going to look at all these different unique skills in our own fields, we got to be able to use things like where you're at, where you're going, momentum, velocity, and use them in the way so that we can all. So we did it, for example, getting all on the same page about position, motion. We're doing that right now for this physics. Yeah. How are you celebrating getting